Hey everyone, welcome back to another video of nothing but factoring. This time we're going to be factoring quadratic trinomials where the first term has a lead coefficient that is not 1. And we can see that in this one, first example, which we'll just jump right into. This one has a 3 as a lead coefficient. So the modification we're going to make to our diamond problems is in the red square. Instead of just putting a 2, we're going to put a plus 3 multiplied by a plus 2. So how much is positive 3 times positive 2? That's positive 6. The white square is going to be just like normal. We'll put a plus 7 there. And then now we're going to complete the diamond problem just like we always do. We need two factors that will multiply to make a 6 and will add to make a 7. So what are the factors of 6? Well, we can do 1 times 6, and if we add 1 times 6, we do get a 7. So we can stop right here. This is the number that we're looking for, 1 and 6. So in the blue, we're going to put a 1, and in the yellow, we'll put a 6. And in order for these two to add to make a positive 7, we're going to need a positive 1 and a positive 6. That's the regular diamond problem that we all know and love. But here, because we have a 3x squared instead of just an x squared, we're going to have to make some modifications to the diamond problem. So we're going to write first the 3x squared. This is different. The next thing we're going to write is the blue square, plus 1x. Then we go to the yellow square, plus 6x. And then we finish it with a plus 2. So if you take a close look at what we've done, we've taken the 7x and we've kind of expanded that out into a plus 1 and plus 6. And of course, 1x plus 6x is equal to 7x. So this gray polynomial that I've written is exactly equal to the blue polynomial. Now that I have the middle term expanded out, I'm going to group. So I'm going to group this first one in blue, and let's group this second one in green. And between them, I'm going to put a plus sign. So what does it look like? Positive 3x squared plus 1x plus positive 6x plus 2. Now in the blue factoring group, it looks like both of these have an x. So I'm going to put an x on the outside of a blue parenthesis. But with 3 and 1, those two numbers, there is no number that goes into both 3 and 1. So I'm just going to leave those numbers alone, 3 and a 1. Now the other parts that come with it is this has to be an x, because when I distribute, I have to get a 3x squared, and this has to be a positive 1. So that takes care of the blue factoring group. Let's take a look at the green factoring group. And this time I'm looking at it and I've got a 6 and a 2. And is there a number that goes into both 6 and 2? And the answer is yes. A 2 goes into 6 and 2. So 2 times 3x will give me a 6x, and 2 times 1 will give me a 2. And you'll notice what happened here is the blue factoring group, or the blue parenthesis, and the green parenthesis are exactly the same. Let's highlight them in green. This and this are the same. So we're going to write them together, factored out, 3x plus 1. And then what's left over after I've factored them out? Well, I have an x and I have a 2. So now I'm going to write x plus 2. See how easy that was? And let's write that so that looks really nice for you. This is a 3x plus 1 and an x plus 2. Okay, so there's our first problem. Let's take a look at the second problem in nothing but factoring. We've got 2y squared plus 5y plus 3. I notice that the first term, the quadratic term, has a 2 instead of a 1. So I'm going to multiply. 2 times 3 is 6, and that's a positive 6. And a positive 5 will go in the white square. The number in the red square is positive, so I know I need to add my factors. What are the factors of 6? Well, it is 1 times 6, and if I add those factors together, I get a 7, which is not what I'm looking for. How else can I make a 6? 2 times 3, and if I add those factors, I get a 5. So this one is wrong, this one is correct. We need a 2 and a 3. And in order to get a positive 5, it must be a plus 2 and a plus 3. So let's put this all together into our expanded trinomial. We got a 2y squared, and then we'll have a plus 2y, and we'll have a plus 3y, and then we'll have a plus 3 at the very end. Let's write our factoring groups. We've got a 2y squared plus 2y. We'll put a plus sign in the middle, and then we'll get a 3y plus 3. And we'll take a look. From the green group, it looks like, well, they both have a 2, so I'll put a 2. And of course, like normal, they both have a y, so we'll put a 2y there. 2y squared divided by 2y is just a y. 2y divided by 2y is 1. And I can check by distributing. 2y times y is 2y squared. 2y times 1 is 2y, so that's good. We'll put our plus sign, and we'll factor out the blue group. Let's see, 3y and a 3. It looks like I can definitely factor out a 3. 3y divided by 3 is y. 3 divided by 3 is 1. So that's looking really good. Now, both of these groups will have a y plus 1. And that's really the key here, is that they both have a y plus 1. So we'll put a y plus 1. And then what's left over? We got a 2y and a plus 3. So our second group is going to be 2y plus 3. And that is the second one factored. So this is nothing but factoring. We're going to do a third example problem. This time we're getting a little trickier. We've got a 3t squared minus 6t plus 5. Again, I notice that there is a coefficient in this quadratic term. So up in the red box, I'll have a 3 times 5, which is positive 15. And a negative 16 will go in the white box. I notice that the red box is positive, so I need to add my factors. Let's get the factors of 15. 1 times 15, and if I add them together, I get a 16, which is exactly what I'm looking for. So let's put a 1 and a 15 in the blue and yellow boxes. And if I want to make a negative 16, I've got to make both of these negative. Negative 1 plus negative 15 is negative 16. Now, let's write our expanded polynomial, trinomial. We got 3t squared minus t minus 15t, and then plus 5. The blue factoring group is going to be the same. I think I switched colors on the previous one, so let's keep on going with blue. The blue factoring group is going to be the same, but notice how this one starts with a minus sign. So what we're going to have to do is we're going to have to say plus, and we're going to keep that negative sign with the 15t. And it's also going to make a difference when we factor. So let's take a look at the blue factoring group. It looks like I can just factor out a t. That leaves me with a 3t minus 1 plus, and I have to factor out that negative. Whenever this first term in the green group starts with a negative, you've got to factor out that negative. And it looks like both of these numbers are divisible by 5. So we're going to put a 5 out here, and that's going to give me a 3t minus 1. Now that I have my factoring groups done, we've got a 3t minus 1. So we'll put a 3t minus 1. And then we have a t minus 5. So we'll put a t minus 5. And that is the next problem on our Nothing But Factoring video. Let's do more factoring. Nothing but factoring. 7u squared minus 9u plus 2. I notice I see a plus 7 in the front. So we're going to do 7 times 2 is positive 14. Minus 9 goes in the white square. The red square is positive, so we need to add our factors. The first factors of 14 are 1 and 14. They add to make 15. The next two factors of 14 are 2 and 7, and they add to make 14, which is what we're looking for. Now, in order to get a negative 9 out of 2 and 7, I've got to make it negative 2 and negative 7. Now that the diamond problem is complete, let's go ahead and put together our expanded polynomial. 7u squared minus 2u minus 7u plus 2. Now let's get the factoring groups in order. Minus 7u minus 2u plus minus 7u plus 2. Taking a look at that first factoring group, it looks like the only thing that I can factor is a u, which leaves me with 7u minus 2. Now the green factoring group starts with a minus 7u. So I have to factor out that minus sign. 7u, negative 7u and 2, it doesn't look like I can actually factor anything out of them. So I'm just going to factor out a 1. That's what you do if there's nothing that you can factor out of it. So if I factor out that minus 1, I get 7u minus 2. So here's our first factor, 7u minus 2. And here's our second group, u minus 1. And this one's finished too. Let's move on to our next problem. All right, we've got a 6a squared plus 5a plus 1. We notice that the polynomial begins with a quadratic term and a coefficient of 6. So 6 times 1 is 6. Plus 5 goes in the white square. The red square is positive, so we need to add our factors. The first factors are 1 and 6, which add to make a 7, which is not what we're looking for. Now the second pair of factors for 6 are 2 and 3, which add to make 5, which is exactly what we're looking for. Now that we have our diamond problem finished, we're going to expand our polynomial. Next, we create our factoring groups. We'll factor the blue factoring group. And then we'll factor the green factoring group. And now that I have my blue and green factoring groups, I'm going to make a quick check that they match. Yeah, 3a plus 1. And the parts that were factored out are 2a plus 1. And that pretty much does it with this problem. We've got one more to try, and that is this one. 9n squared minus 9n plus 2. So nothing but factoring. 9 and 2 multiply to give us 18 in the red square. Negative 9 goes in the white square. I notice the red square is positive, so I need to add my factors. The first pair of factors for 18 are 1 and 18, which add to make 19. And I'm looking for a 9. The next pair of factors for 18 are 2 and 9, which add to make 11, which is also not what I'm looking for. I'm looking for a 9. The next pair of factors for 18 are 3 and 6, which add to make 9. That is what I'm looking for. So 3 and 6 go into the blue and yellow square. They both got to be negative if I want to make a negative 9. And I'm ready to expand my polynomial, starting with the 9n squared. And then minus 3n minus 6n plus 2. Now I have to make my two factoring groups. 9n squared minus 3n. Always put the plus sign. Negative 6n plus 2. Taking a look at the blue group, it looks like I can divide everything by a 3 and an n. Now taking a look at the green factoring group, it has to be a negative number because 6 is negative. And it looks like I can factor out a 2. Don't forget that that's going to change the sign of everything inside the green parenthesis. Positive 3n and minus 1. And now it's just a matter of rearranging, starting off with 3n minus 1, and then finishing off with 3n minus 2. And that's it. Nothing but factoring. We just did a whole bunch of problems that were quadratic trinomials where the first term was something other than 1. Hopefully this helped you with your factoring, and we'll see you next time here with Ferreria's Math Class.